Let us study about electrical energy and power. To understand this, let us consider a conductor of certain length. As given here. Let us call this as end A and this as end B. And let the potential at end A be called as VA and potential at end B called as VB. Suppose a current I flows from end A to end B, then we can say that the change in potential, which is called as V, that is equal to VA minus VB, and this is a positive number which is more than 0. It is positive, that implies it is more than 0. It is positive because since current moves from end A to end B, we know that current always moves from high potential to low potential. So this is the change in potential. So this V is called as change in potential. Now, if we assume that a charge Q enters or leaves the conductor in time delta t, then we can say that this Q is I into delta t. That is because current is given by charge by time, or charge is current into time. Now because of this, there will be a change in potential energy, and let us call delta U as the change in potential energy, because when the charge moves from end A to end B, there is decrease in potential, and that would lead to change in potential energy, and this is given as U final minus U initial. In this case, it is equal to potential energy at the point B or end B, which is called as UB minus UA, and this is equal to, it will be Q into VB minus Q into VA. That is equal to, Q is common here, it becomes VB minus VA, that is equal to minus of Q into V. That is because V is given as VA minus VB, but what we have is VB minus VA. So we can rewrite this saying that delta U, which is Q, is I into delta T into V. This is what is delta U, and this is negative, which is less than 0. In case of a conductor where the charges do not make any collision, in that case energy remains conserved. That would mean that change in potential energy plus change in kinetic energy is equal to 0. That is because energy remains conserved. This would imply that delta K, which is change in kinetic energy, is equal to minus of delta U, that is equal to minus of minus into I delta T. Therefore delta K is I into delta T, there is a V here, into V. So this is a change in kinetic energy. But in reality, in practice, suppose if you apply potential difference with the help of a battery, then the battery will accelerate the charged particles, because of which they will gain energy. But when the charges move, the charges will collide with the atoms in the material as well as with electrons. So when the charges collide with the electrons or atom material, the electrons which have gained the energy because of the applied field, there is a field which has been applied because of the battery, the electric field will exist in this direction. This electric field will accelerate the charged particles, because of which the velocity will increase. But the energy whatever they gained, that energy will be lost in collisions with the atoms or electrons. Now when the electrons transfer energy to these atoms, for example, look at this atom. If an electron or charge transfers energy to this atom, it will start to vibrate more vigorously. The more and more it vibrates, this vibrations is seen as heat. So whatever energy the electrons transfer by collision, that we call as delta E. So delta E is energy which is transferred to the atoms, and this is seen as heat. Therefore, you can say that delta E is nothing but I into delta T into V. This is the heat which is seen or which is dissipated. If we divide this by time, then energy by time is called as power. So the power which is dissipated through resistor is called as P. That will be I into V into delta T by delta T. Therefore, the power dissipated in the circuit or resistor is I into V. If you use Ohm's law, we can express this in terms of I and R or V and R also. That is, if we write V is equal to I into R, then the power is dissipated is equal to I into V is I into R. So power is equal to I square into R. Similarly, we can write in terms of V and R also. So this is the power which is dissipated in the resistor. Now this power is very, very important because this has a lot of applications, like in water heater or electrical heaters. The devices which work on resistance being heated is basically from this principle only. So the power dissipated is given as I into V. Wherever we find any application where the heat is required, whether it is used to heat water or seen as light or seen as energy, in every case this is the principle which has been followed.